Welcome to David Alexander Maths Tuition. This is Chapter 4D on points of intersection. So here's an example. We have been asked on the same axes to sketch two curves, x plus 2 and x minus 3 squared. So a quadratic and a cubic. So we know that the x-intercepts of the x plus 2 will be 0 and -2. So that's easy enough. So it goes through the origin, goes through -2. So and it's a positive x squared, so it will be a U-shaped graph like so. And the cubic goes through 0, and the other solution is positive 3. Now this is a repeated root, so therefore it's not going to cut through at 3, it's just going to touch 3. Now if it's a positive cubic, it will go up, then down, then up again. So it's going to go up through 0, so that's one point of intersection. Then it's going to turn around, not drawn this brilliantly, and touch the 3 and then zoom off again. Okay, so one obvious coordinate of the point of intersection, they both go through the origin, so that is 0, 0. Okay, so let's take a look at the proper sketch here. So we've got the 0, 0. And we can see here that the cubic is just turning around at 3. So we need to work out this other x-intercept here. Now, is that the only one? At the moment it looks like, and if you put it on Desmos, it probably will always look like there's only two intercepts here. Now, if you look at the green line, the quadratic is going pretty steeply, but this cubic is going even more steeply. So we will, somewhere up here, we'll get a third point of intersection. So what I'm going to do here to work them out is I'm going to expand the bracket, so that is x squared plus 2x. The x minus 3 squared, that is x squared minus 6x plus 9, multiplied through by x is x cubed minus 6x squared plus 9x. So I'm going to set them equal to each other so that I can work out the points of, or the x values of the points of intersection. So make that equal to x squared plus 2x. Take away an x squared from both sides, so that's going to be x cubed minus 7x squared. Take away 2x from both sides, plus 7x equals 0. Now this cubic equation has got an x in everything, so I can take out an x, and that will leave me with x squared minus 7x plus 7 equals 0. So here I'm getting my x solution of 0. Well, that's the one we already know about. We want the x value for this one and the one that we can't see. Now I can't factorise x squared minus 7x plus 7, so I'm going to use the quadratic formula. So grab the calculator. A is 1, B is -7, and C is positive 7, and I'm getting my one solution as 7 plus the square root of 21 over 2, which is approximately 5.79. And my other x value is 7 minus the square root of 21 over 2, which is approximately 1.24. Okay, so this is clearly the 7 minus root 21 over 2, but because that's approximately 1.24, but I can't see the 5.791. This is the one that we can't see off the top of my screen clipping here. Okay, so anyway, it doesn't really matter. We've got the two x values here. So 7 plus or minus root 21 over 2. So I need to work out the corresponding y values. So all I'm going to do is, well, I could either I'm going to type this into my calculator, and I'm just going to square it and then add two lots of it. So answer squared plus 2 answer from the 7 plus root 21 over 2. I'm getting 49 plus 9 root 21 over 2, and when I substitute this x value into the x squared plus 2x, I'd much rather substitute it into the x squared, into the quadratic than the cubic equation. For this one I'm getting, well, fairly similar except it's minus, so 49 take away 9 root 21 over 2. So I've got, there are 3 points of intersection, 0, 0, 7 minus root 21 over 2, comma 49 minus 9 root 21 over 2, and the one we can't see, which is 7 plus root 21 over 2, comma 49 plus 9 root 21 over 2. A fairly tough one, that one. Okay, here's another example. On the same axis, sketch the curves with equations x minus 4 and x squared 2 minus x. So quadratic, cubic. So our x-intercepts are 0 and positive 4. Okay, so there is 4, there is 0, so it's going to look like that. And this has got a repeated root at 0, and what are we going to do with 2 minus x? We need to be careful. Let's make 2 minus x equal 0, so therefore 2 equals x. Okay, so this is my solution of 2. Right, so it's cutting through here. Okay, so x squared times negative x is, so this is a negative cubic, so it's not going to go up, then down, then up again. It's going to go down, then up, then down again. So it's going to go down and hit the origin. Now the question is, where is it going to go down? Is it going to come down here, or will there be an intercept here? I'm not really sure. I mean, I'm sure, but I'm putting myself in your shoes. You might not be sure. So you might draw it as, remember, it's not cutting through 0, it's just touching 0. So let's assume that it misses and it just touches like so. So we know we've got one coordinate is 0, 0, and then it's going to go up and then back down through 2. Okay, so we've definitely got one point of intersection here. We've definitely got the origin. The question is whether we've got another one over here. Now, I've plotted it into Desmos. Well, first of all, obviously in an exam, you're not going to have access to Desmos. So we can work it out algebraically by setting one equation equal to another and seeing how many solutions we get. Now, we will actually end up with a third solution here. So we do get the 0, 0, and this one here. We knew about this one on the furthest one on the right, but we weren't sure about another one over here. So let's expand the brackets. X squared, take away 4x, 2x squared minus x cubed. Let's make them equal each other. So I'm going to subtract an x squared from both sides. So 2x squared minus an x squared is just 1x squared. So that's x squared minus x cubed. So I've subtracted one of the x squared plus 4x, and that equals 0. Okay, so let's write this in descending powers of x. So x cubed plus x squared plus 4x equals 0. I can factorise out the x. That's going to be x lots of minus x squared plus x plus 4 equals 0. So here I'm getting a solution of 0, and I'm going to use my quadratic equation solver for the minus x squared plus x plus 4. So a is negative 1, b is positive 1, and c is 4, and I'm getting another solution of 1 plus the square root of 17 over 2, and 1 minus the square root of 17 over 2. Okay, so 1 plus the square root of 17 over 2 is 2.56. So this is the 1 plus root 17 over 2, and this is the 1 minus the square root 17 over 2. There we go. So we've got the 0, 0, that's sorted. So when x is 1 plus the square root of 17 over 2, we've got the 0, 0, and we also need to deal with the 1 minus the square root of 17 over 2. What is the corresponding y value? Okay, so on my calculator I've got 1 plus root 17 over 2 on it, so I'm just going to do answer squared, take away 4, answer, and I'm getting 5 minus 3 root 17 over 2, and for 1 minus root 17 over 2 I'm just going to square that and subtract 4 lots of it, and guess what, I'm getting 5 plus 3 root 17 over 2. So here are the coordinates of the 3 points of intersection. 0, 0 is the easy one, and then the 2 are the fairly horrible ones. So yeah, pretty nasty question, that one. Perhaps in a real exam you might get values that were a bit kinder than some pretty horrendous surds. Okay, so here's another similar question on the same axis. Sketch the curves with equations x minus 3 and 2 over x. So x minus 3 cuts through the x-axis at 0 and plus 3. It's a quadratic, x squared minus 3x. So let's just do a quick sketch of that. So it's going through at 0 and 3. So it's going to look something like that. Now 2 over x, well 1 over x looks like that. In fact 2 over x looks pretty similar. So there we go, and bottom left. Okay, so we can see that there is only one point of intersection. So what are the coordinates? Okay, so all we need to do is set the two equations equal to each other. So x squared minus 3x equals 2 over x. Multiply through by x, so x cubed minus 3x squared equals 2. Subtract the 2. X cubed minus 3x squared minus 2 equals 0. So we're going to use our cubic equation solver on the calculator. So menu setup, press the minus button, polynomial degree 3. So a is 1, b is negative 3, c is 0 because there's no x's, minus 2 for d, and we are getting x equals, let's just to one decimal place, 3.2. So actually that looks vaguely believable that it's just slightly more than 3, so my sketch wasn't horrific. Are there any other solutions? Well, I'm not expecting any other solutions, but what does the calculator do if I press equals again? I am getting another solution, but actually it's one of those weird ones with an imaginary number, so we can just ignore that one. And x3, again, another imaginary number. So there's only one point of x intersection, which is where x is 3.2, and what is y? Well, y is 2 divided by x, so 2 divided by 3.2 is 0.625. Although I did only substitute in 3.2, not so a rounded answer rather than the accurate one. But anyway, I'm sure we can make that more accurate if we needed to. But the key thing is understanding that you just need to make the two equations equal each other, rearrange and solve. And if you get an imaginary number, then obviously that is not a solution. On the same axes, sketch the curves given by y equals x plus 2 cubed and y equals 2x minus 1. Explain how your sketch shows that there is only one real solution to the equation. So we better make sure that we draw a sketch that only has one solution. So x plus 2 cubed, that has got a repeated root of negative 2. So this is a cubic. So it's going to cut through at minus 2. That's the only point of intersection. So that means as it's a positive cubic, it's going to go up, slow down, and then move back up again. And y equals 2x minus 1, there is a root of 0 and plus 1. So the quadratic one is quite easy to sketch. It's going through 0 and plus 1, so it's going to go down through the origin, turn around and go back up through 1. Now the cubic is cutting through at minus 2. So I know it's going to come up, go through here, and it's going to continue upwards. I also know, remember x plus 2 cubed is x plus 2, x plus 2, x plus 2. So if I were to expand the brackets, I'd get x cubed plus a certain number of x squareds plus a certain number of x's plus 8. So I know that it's going to cut through 8. The question is, once it's gone through 8, I don't need to mark the 8. Is it possible that it might snag the line over here? Well, it's not. It can't, because we know it's going to definitely cut through this part of the quadratic curve. So I need to make sure that it doesn't. It's not going anywhere near this one. Also, remember, a cubic will go much more steeply than a quadratic. So my cubic is going to come up through here, through negative 2, and then up through here through minus 8, and then it's going very steep, so steep that we know it's not going to interfere with this one. So here from my sketch, I have shown that there is only one real solution. And again, here's a clipping from Desmos, so we can see the repeated roots of negative 2. We can see the quadratic going through the origin and through plus 1, and we can see that one root there, and we can see just how steeply the cubic curve is going. We can see that it does go through positive 8, but it's much steeper than the corresponding quadratic one. Okay, so here is one final example. Sketch the graphs of negative x cubed and 4 over x. Okay, so 4 over x, I'm just going to draw it exactly the same as I would as if it was 1 over x. So top right and bottom left. Okay, and negative x cubed. So positive x cubed goes like so. Negative x cubed goes down, slows down, and then continues on its way down. So it's coming down from up here, and it's going to go through the origin, and then it's going to continue on its way down. And we can see there's absolutely no interference between these two curves. The negative x cubed is only going to occupy the top left and the bottom right, whereas the 4 over x occupies the top right and the bottom left. So that's why there are no solutions, because you can see from the sketch there are no points of intersections. The curves don't cross, so therefore there are no real solutions to the f of x equals the g of x.